Welcome to Hydrology Hub. In previous lectures, I demonstrated the dam break analysis using HEC-RAS. In this lecture, I am using HEC-RAS map layer calculations for the creation of flood hazard map. Flood hazard map is an important input for the preparation of emergency action plan, that is EAP. The dam hazard potential classification is a direct result of flood hazard analysis of different scenarios that can occur. However, one of the challenges in this type of assessment is the fact that the degree of hazard varies with the severity of the flooding and is affected by the flood and its hydraulic behavior, the topography, population at risk, and emergency management. Once the flood hazard of the dam event, that is failure scenario, have been quantified, the potential of flood wave once the flood hazard of the dam event, that is failure scenario, have been quantified, the potential of the flood flow to cause damage or danger can be indexed against vulnerability curves linked to meaningful hazard thresholds. A combined set of hazard curves is shown here. It is also tabulated as. Now, using these sets of curves and conditions given in the table, we will write an script to compute the flood hazard map in HEC-RAS using the velocity and depth map already generated in HEC-RAS by dam break analysis. So, let's start. First of all, in RAS Mapper, where our dam break analysis results are already available, we will select the results and our saved plan. Here it is DBA P1 or DBA underscore P1. Now right click in the DBA underscore P1. A window will open and here you select create a new calculated layer. Now a raster calculator window will open. Click plus sign in layers. It will open a new window named create raster layer definition. Here select plan as DBA underscore P1, map type water surface elevation, animation behavior as fixed value, profile as max, and name of the variable as WSE. Now click add variable. Again, in the create raster layer definition window, select plan as DBA underscore P1, map type velocity, animation behavior as fixed value, profile as max, and name of the variable as V. Now click add variable. Close this window. Now select terrain, check the radio button, write or copy the script for calculation of hazard map here. Remember that the name of the terrain in the script should match with the name of the terrain mentioned in the right window of raster calculator. Hence, it is terrain 11, so we will write terrain 11 in script also. Now click in the check code button to compile the code. If code is correct, it will show code compiled successfully. While calculating this map layer, you provide name to the calculated layer. Your new map layer will be saved with that name. So I will provide here the new name for the calculated layer as hazard map. Now click on the button create layer. Now a calculated layer is added in your map results in HEC-RAS. Now right click in hazard map which is calculated recently and select first option, that is image display properties. A new window will open, that is hazard map layer properties. In the surface, stretch is selected. Click on the pull down menu and select discrete and then click edit. A new window will open named surface fill. Here select min as 1 and max as 6 and number of values as 6. Select appropriate color ramp. Now close this window. Your calculated hazard map layer is classified in 6 classes. Now right click on the calculated layer, that is hazard map, and select export layer and then export as raster. Select the destination folder, select format as gotif, that is .tif, and give the name of the layer as hazard and save. Now a window will open, export raster, click OK here. It will start exporting raster. In this lecture, we learned how to create flood hazard vulnerability map in HEC-RAS from dam take analysis results. How to classify the displayed flood hazard vulnerability map in 6 classes, and how to export flood hazard vulnerability map as a TIFF file. If you found this helpful, like, subscribe to Hydrology Hub, share your queries in the comments. Keep learning, keep modeling. This is Hydrology Hub.